into bridging the machine learning skill gap. This session is all about the missing paradox, or we can say black box problem. The machine learning paradox. Machine learning software is easier to use than ever before, even with low level technical knowledge. This creates a critical risk. Practitioners become unaware of design decisions, assumptions, and limits of the algorithm they use. This is the black box problem. True mastery requires looking inside. So let's see this, how we can resolve this problem. The magic behind successful machine learning algorithm is blocked by daunting scent of prerequisite knowledge. This means first we need to look into the prerequisite knowledge, prerequisite concepts, then move forward to machine learning parts. The knowledge gap separates practitioners from true expertise, especially for those in computer science who are often not deeply trained in mathematics and statistics. So let's look into the three core prerequisites: programming languages and data analysis tools, large scale computation and associated frameworks, mathematics and statistics, and how machine learning builds on it. So these are the three core prerequisites. The bridge to mastery. So if I talk about mathematics for machine learning, the book is a self-contained textbook designed to solve this exact problem. Its purpose is to bridge the gap between mathematical and machine learning text. It introduces the fundamental mathematical concepts with a minimum of prerequisites, aiming to narrow or even close the skill gap. This book is not another math textbook. It provides the mathematical background needed to understand them deeply, and it's also free. So, if we look into an architecture of learning, this book is built into two parts to guide your learning journey. Part 1, Mathematical Foundations, establishes the core mathematical tools needed to understand machine learning. Part 2 is the central machine learning problems, uses these concepts to derive 4 central machine learning methods from first principles. So there are 2 ways we can read this book: bottom up. The most preferred way, start with the mathematical concepts in part 1 and then build up to applications part. Top down, start with an ML problem in part 2 and refer back to mathematical foundations as needed. So if we have to look into the part 1, the mathematical foundations. Part 1 lays out the solid mathematical groundwork required for machine learning. The core topics are linear algebra, the study of vectors and matrices, the language of data; analytic geometry formalizes concepts of similarity, distance, angles between vectors; third, matrix decompositions break down matrices into constituent parts to reveal data structure and improve computation. Vector calculus. If we talk about the vector calculus part, it provides the tools to find gradients essential for model optimization. Fifth is probability and distribution, a framework for quantifying uncertainty. Sixth is continuous optimization, the methods for finding the best model parameters by maximizing performance. A detailed look at the foundations, algebra, and geometry. So we'll look into the detailed topics that we need to understand and cover for machine learning: linear algebra, systems of linear equations, matrices and vector spaces, linear independence, spaces and rank, linear mappings, affine spaces. Chapter 3, Analytic Geometry, Norms, Inner Products, Lines and Distances, Angle and Orthogonality, Orthogonal Projections, Rotations. Chapter 4, Matrix Decompositions, Determinant and Trace, Eigenvalues and Eigenvectors, Closed-sky decomposition, agent decomposition, and diagonalization, singular value decomposition, SVD, matrix approximation. Let's look into chapter 5 vector calculus, differentiation of univariate functions, that means one variable, partial differentiation in gradients, gradients of vector valued functions, backpropagation, and auto difference. Then we have high order derivatives, multivariate Taylor series, chapter 6 probability and distributions, construction of probability space, sum rule, product rule based theorem, Gaussian distribution, conjugacy, and the exponential family, change of variables in inverse transformation, etc. Chapter 7 is continuous optimization, optimization using gradient descent, then constraint optimization of Lagrange multipliers, convex optimizations. So the second part is building the four pillars of machine learning. Part second demonstrate the power of the mathematical foundations by using them to derive four central machine learning methods from the ground up. So after we learn the foundational basics, we will be moving forward to the part second. Pillar 1, linear regression, finding functions that map input to real valued outputs. Part 2, dimensionality reduction, PCA, finding compact lower dimensional representation of high dimensional data. Pillar 3 is density estimation, GMMs, finding a probability distribution that describes a given dataset. Pillar 4, classification, SVM, assigning inputs to discrete categories. If we look into a detailed look at the pillars, modeling and regression. Chapter 8, when models meet data, data models learning, empirical risk minimization, parameter estimation, probabilistic modeling and inference, directed graphical models, model selection. Chapter 9 is linear regression, problem formulation, parameter estimation, maximum likelihood, Bayesian linear regression, maximum likelihood as orthogonal projection. So these are the mean, and then if we have a detailed look at the pillars PCA, GMM, and SVMs. So we have maximum variance perspectives, projection perspective, eigenvector computation, PCA in high dimensions, key steps of PCA in practice, latent variable perspectives. If we look into Gaussian mixture model, parameter learning via maximum likelihood, EM algorithm, latent variable perspectives. And if we look into separating hyperplanes, primal support vector machine, dual support vector machine, kernels, numerical solutions. So based on this, a guided book, this is a guidebook for every stage of the journey. The book is designed for three types of interaction with machine learning, analogous to music. The astute listener is the one, the user, and the critic, focusing on extracting insights using off the shelf tools and asking important questions about ethics, fairness, privacy. The experienced artist is the practitioner, a data scientist, or engineer who plugs and plays different tools and libraries to perform feats of production. The fledgling composer, the researcher, and the creator develops new methods and extends existing algorithms by understanding the mathematical basics of machine learning. So basically, this is a path of transformation. This book provides the foundation to move from being a user of machine learning to a creator. Listeners will be able to use their domain expertise to build better, more robust machine learning systems. Artists will be able to understand the benefits and limits of their favorite methods and to extend and generalize existing algorithms. Composers will be able to uncover relationships between different tasks and propose novel approaches to many challenges of learning from data. So, this book is designed for active learning. The book is structured to facilitate understanding and practical application, worded examples and exercises. Every chapter includes examples and exercises to test your understanding of the concepts. Programming tutorials, practical Jupyter notebooks are available on the book's website to explore the properties of the machine learning algorithms built for diverse learners. The content is aimed at undergraduate students, evening learners, and the participants in online machine learning courses. So this book is authored by experts vetted by the community. The authors are Mark Peter, Faisal, and Changsu. So based on this, we can see they are the main people behind this and a community effort. The book has been greatly improved by the generosity of the online community, who have suggested improvements, found bugs, and proposed clarification via GitHub. So let's begin your journey to mastery. The complete textbook is freely available to download at the given link. This self contained textbook bridges the gap between mathematical and machine learning text, introducing the mathematical concepts with minimum of prerequisites. Grow from consuming machine learning to creating it and understanding it. So, thank you so much for listening to this and understanding, and let's make this practical too.